Alright, welcome to our 18th video on writing a clojure-like Lisp for Swift with Claude code. Today I want to start to kind of finish up our namespace implementation, limited as it is, and get it so that we can actually load some Clojure code as in clojure.core for kind of as our base library for our Clojure implementation. So today we're going to add the ability to load code from the library resources directory, load clojure.core, and have an ns macro so you can have your own namespaces in your own code as well as in the library. So here's our prompt. Add the ability to load some of the clojure.core from a file that lives in SwishKit's resources. In the resources, create a directory called clojure, and then create a file in the directory called core.clj. That is loaded when SwishKit is initialized. Native functions should be registered first so that we can use those in the code. In the core.clj file, add a define macro that simplifies defining functions. The first line of core.clj should be ns clojure.core, which means we will need a special form called ns. For now, the special form will take one argument, which will be the name of the namespace. It will basically just find or create the namespace if it doesn't exist, and then switch to it. Ask any clarifying questions. Most behavior should be as close to normal Clojure behavior as possible, given our current implementation. So we're in plan mode. Let's go. As usual, we're starting with a clean slate. It's going to read everything and figure out where we are and make a plan. So in the meantime, if you like what I'm doing, please like and subscribe to the videos. There's a link below where you can buy me a coffee if you'd like and support my work. And I'm also looking for contract gigs in Clojure or in Swift with iOS development. So if you need some help with that, it could just be consulting. Maybe you need some advice. Hit me up. You can DM me on Twitter at Rod Schmidt, or go to infinitenail.com and contact me there. Wow, it's running 3 Explore agents. That's different. Alright, it's finally read everything and it's writing a plan. That can sometimes take a while. Spent 3 minutes reading files. Alright, we have a plan. Plan, load clojure.core from a resource file. SwishKit currently bootstraps entirely in Swift. Native functions are registered in register core functions, but there is no Clojure level standard library. The goal is to add a resource file, clojure.core.clj, that is evaluated startup after native functions are registered, allowing Clojure level definitions like defin to live in Clojure rather than Swift. This is also requiring adding a ns special form so that file can declare its namespace on the first line. So first of all, to package.swift, we're going to add a resources directory. And then we're going to add into that, we're going to add our core.clj with the namespace, with a def macro, which is what we want. Okay, that looks good. In evaluator.swift, we're going to add an ns case for the value list for the special form. Okay. And then we're going to reorder init to bootstrap ns star before loading core. Current order registers native to create user, create set ns. New order register native, set ns, clojure core, load core.clj, create user, set ns. Okay, there it is. There's the code. That should work. evaluator plus bootstrap.swift contains the resource loading logic, must live inside Swish kit, so bundle module refers to the right bundle. Load core library. Okay. Fatal error is appropriate. Eval calls. Okay. Verification. Swift build confirms package compiles and resources are bundled correctly. Swift task existing test should pass unchanged. REPL smoke test. All right, I think that looks good. So let's just go ahead with this. It's all ready to build and test. Up above, I saw that it was doing things in parallel. Seems to have gone pretty fast. We've got some errors on our tests, apparently. It's going to try and fix those because it can't find the resource bundle. I know that the resource bundle is generated by Swift at compile time, so that might be part of the problem. A lot of times if you just recompile, it goes away. Yes. Alright, all the tests pass now. Now it's going to do a smoke test on the REPL. Let's do yes and don't ask again. Alright, it says everything works. Alright. Let's run the test ourselves, make sure that goes. Everything passed. I want to look at the code that it changed before we actually give it a try. So let's look at our package.swift. You'll notice it added a resources to our package, and we can find that right here. And in core.clojure we've got ns-clojure.core and our defen macro. And the other thing that it had to add, well, we got the evaluator bootstrap file for loading the core library. And we've got the evaluator, which first it registers the core functions, and then it loads it, and then it creates the user. So that's right. And we've got the evaluating of the NS special form. All right, everything looks good. Let's give it a run. All right, so defen should be available to us. So let's make a function. And we should call it. So that's our defen is working, so it's loading clojure.core. And we should have a ns macro, which we do. Let's make an X and make sure it's in the right namespace. It is. So if we go back to user and try rod, it's not there, but if we can say rod X, and there it is. All right, so that's looking good. Everything looks like it's working. That's a step in the next direction. So going forward, we can add more functions to clojure.core in actual Clojure code. But if we look at let's look at the to-do that we have here. We can add all kinds of more functions for all kinds of things. Namespaces being among them. We can create a clojure.string, which that could be another file in the resource file that's loaded. We can add a bunch of literals and more functions. So basically, we're just going to keep building out our implementation. So thanks for tuning in. Like I said, like and subscribe, buy me a coffee, and I'll see you next time.